Let's continue with another example with function notation. And I'd like to take a look at the following example. Let's let f of t equal t squared minus 3t plus 4. And what I would like us to do is I would like us to evaluate the following. We're going to break this up into 3 parts. So part 1, I want you to find, or it's the same thing as saying evaluate f of 2. Okay, so finding f of 2 means every time we see a t, I'm going to turn that t red over here, I want to replace that t with the number 2. So we're going to go back to that function, f of t, and again, every time I see a t, I'm going to replace it with the number 2. So substituting in, we're going to get the following. F of 2 is equal to 2 squared minus 3 times 2 plus 4. And that is the same thing as saying 4 minus 6 plus 4. And that is the same thing as saying negative 2 plus 4, which is equal to 2. So f of 2 is 2. What that means is if we were to graph this function, when x is 2, y is 2 as well, this is an ordered pair that's on the function. Now let's break it up into its next part. So evaluating for 2 gives us 2. When we input a 2, the function outputs a 2. Now I would like for us to evaluate the next part, and we're going to use that same function. So I'm still going to go back to f of t is equal to t squared minus 3t plus 4. And this time around, I want us to evaluate f of t plus 2. Okay, so now it's a little different. Now we're dealing with substituting in a binomial instead of just substituting in a numerical value for this. But the general idea is the same. Anytime I see a t, which we have over here in this function, which we have over here in this function, and which we have over here in this function, I want to replace that t with t plus 2. So substituting in initially, we get the following. We get t plus 2 quantity squared minus 3 times t plus 2. Oh, running out of some space here, so I'll just follow up that next bit with it, plus 4. Okay, so let's write it out. So it looks like this. We have t plus 2 squared minus 3 times t plus 2 plus 4. Okay, so we're going to use order of operation. Order of operation says that we're first going to exponentiate t plus 2 times t plus 2 minus 3 times t plus 2 plus 4. And here we're going to FOIL, so we get t squared, first 2 plus 2t plus 2t plus 4. Distributing in the negative 3 to the next 2 terms, we get negative 3t minus 6, and then we're just going to bring down our plus 4 over here. And now let's take a look at this and combine as many like terms as we possibly can. So I have t squared, no other square terms. In terms of any t terms that I may have, I have t terms here, I have t terms here, I have t terms here. So combining all those t terms together, we have 2t plus 2t, which gives us 4t, minus 3t is 1t. So you don't have to write the 1, but we can write the 1 just to be consistent. And then in terms of constant terms, let's see, I have plus 4, I have minus 6, I have plus 4. That's going to give me 4 minus 6 is negative 2. Negative 2 plus 4 is 2. So substituting in t plus 2 for this function, f of t plus 2, gives me t squared plus 1t plus 2. And let's break this up into one more component. And again, we're going to use that same function that we were using with before. So if I have f of t is equal to t squared minus 3t plus 4, I would like for us to find or to evaluate, both of those terms mean the same thing, but here let's call this f of t minus f of 2. So what makes this one a little bit different than the other one that we were just doing? Notice here that I have 2 functions that I'm breaking this up to. My first one is f of t, and my second one is f of 2. Well, let's talk about that f of t. Do you see f of t anywhere else? Of course you do. We see f of t right over there. And we know that f of t is the same thing as saying t squared minus 3t plus 4. So substituting this in, and we're just going to substitute it into little bits and pieces, we know f of t is t squared minus 3t plus 4. So let's just leave that there. And now let's take a look at f of 2. Well, that should sound familiar as well, because if we go back to what we did at the beginning, that first step over there, we know that f of 2 is equal to 2. Right? We found that out right here, that f of 2 is equal to 2. So going back to that third problem, we know already that f of 2 is equal to 2. So what this is asking us to do is this is asking us to take f of t and subtract from that f of 2. Well, what do we know about f of t? We know f of t is t squared minus 3t plus 4. So t squared minus 3t plus 4. And let's just copy down our subtraction symbol from over here. So here's our minus. We also know that f of 2 is the same thing as saying 2. So we're going to subtract from that 2. Okay, so putting this all together, we get f of t minus f of 2 is the same thing as saying t squared minus 3t. And hopefully you see that over there we have that plus 4 minus 2, combining those two like terms, plus 2.